සෝපගේ මයි පියාබන්න නැහැ බාධා දකින්න හීන දකින්න ආයෙත් නැහැ බාධා ගමේ නගරයේ කන්දේ තැනිතලාවේ
හීන දකින්න ආයෙත් නැහැ බාධා
අඳුරේ
SyZyGy Online Mahakethara.
Good evening, everybody. So hope you all met me last week in the Zoom session, but in a different classroom. So today our plan is slightly different because we are starting the online classes, lessons from today onwards in a very special place, one of the best online platforms in the country, that is SyZyGyOnline.lk. Online Mahakethara, right? So yes, if you all remember, we were discussing last couple of days, in case, I have to add that part, in case if you have missed the last week lessons, we can get the recordings. So we'll tell you the procedure to get the recordings throughout the day today. My concern is not that today, because we are starting 1.2 today. 1.2 means last week we were discussing 1.1. 1.1 is the introduction to physics. Now today our plan is, broadening the concept and developing this lesson to do the past paper level work. So people who have missed the last week work, I will just go to the board and add some info. Right. So here it is 1.1, 1.1, right? 1.1, that is introduction to physics. So simply what we did, what is physics? What is physics? So we were discussing what is physics, right? So what is physics? And simple answer, we brought out everything, study of everything. Study of everything. Everything means everything. It is a little bit difficult because we can't define this and that. Everything. For an example, I talk here, so you listen to me. So you listen it through sometimes your mobile phone, sometimes the laptop, whatever the device. That is development of the physics concept. So we are in a studio, we are broadcasting what we do, we are writing on a whiteboard, using black pens, we are using smart boards, everything physics. Not only these parts, not only very high-tech work, even the simple day-to-day life activities. For an example, sun rising, sunset, rainfalls. When you go to the beach, waves coming to the shore, and sometimes it is very calm and sometimes it's a disastrous like a tsunami. So everything. We were talking about this last week, and I repeat this idea to you in case you have missed anything. I want to because we'll give you the recordings of the first lesson, and that is what physics is. Now today we are extending this. One more thing. This part is not directly coming to the exam. So people who are more concerned about exam, no, this part is not there for the exam. This part is basically there only for what? Only for? Yes, understanding purpose. Before you start learning something, you need to know what you're going to learn. So if you don't know what is physics, you are in a problem, you can't understand what you're going to learn, why are we learning them, etc. So today we are going to 1.2. That is a very serious part again. Physical quantities Physical quantities. What is this? What is a physical quantity? Why are we learning physical quantity? That is essential to understand. Why are we learning physical quantity? Because we are learning physical quantities to understand everything. To understand everything, we must understand everything. We must know how to learn physics. How to learn physics. How to learn physics. How to learn. How to learn physics. Right? How to learn physics. To learn physics, to develop a process. We need to learn about smallest element of physics. To learn about smallest element of physics, we need to understand what is smallest element of physics. What is smallest element of physics? What do you think? What is smallest element of physics? That is simple. That is a physical quantity. Physical quantity is the smallest element of physics. Smallest element of physics. To recognize the physical quantity, right? We need to have basic understanding of three things. Honestly speaking, two very important things. Without them, no physical quantity. Other than those two, we need an supplementary, some parts. Now, tell me, what do you think? What is a physical quantity? Now, remember, when I ask questions, it's a very interactive session. I am logging into the WhatsApp group as well as you can chat through the Zoom. So we are able to check it throughout the day. So they have given us the access to the WhatsApp group as well as for the Zoom session, Zoom chat. So I expect you to add answers in the WhatsApp group or the Zoom chat about what? What is the plan? What is a physical quantity? I expect at least one or two to drop answers here. What is a physical quantity? Physical quantity is right. See at least one or two people. Smart people, brave people. Right. I got some answers. Can be measured. Nuha, very good. Well done. Nelly, quantities with a magnitude and a direction. Nelly, I like the first part, not the second part. Very good. Nelly connected. Nuha connected. Well done. What else? Only girls? Right. Dilina Veragama? Quantities that can be measured? Okay. Francis, the smallest element in physics. Yes, I'm asking, how do you recognize, how do you define it as the smallest element? What are the features of the smallest element? Smallest element can be measured. So let's start from there. Now Nuha, Nelly and Dilina, all three telling the same thing. Senuti, quantities have units. Wonderful. Quantities, yes, Sandhu saying quantities which are tangible, visible to the naked eye. Farah, can be written using a number and a unit. Amisha, quantities which have magnitude, direction and unit. Quantities, did I miss anyone? D1498. Can you just change to your name so then we can recognize you easily and talk to you easily? D1498. The quantity, that magnitude directly or indirectly? Quantity, that magnitude measures. Okay. Right, let's go for this. That's a good chat. I like the group. That's a good start, and I think we can learn this a little bit more interestingly because people were good. They have added nice comments, nice definitions. They feel, yes, very good. Quantities with magnitude and unit. magnitude and unit. The direction, some people say direction. Direction is a feature of physical quantity. What I asked was to consider it as a physical quantity. What are the main requirements? Two main requirements, most essential requirement. එකනේ physical quantity එකක් කියලා හඳුන්වන්න නම් ඒ physical quantity එක අඳුන ගන්න ඕන ප්‍රධාන සාධක දෙකයි. මොනවාද ප්‍රධාන සාධක දෙක? විශාලත්වය magnitude and unit එකකයක්. Unit and a magnitude. That's the most important part. Yes, direction, considering a direction, so it is with a direction, without a direction, scalars, vectors, they are features of physical quantities. Physical quantities can be divided into two main parts based on their availability of a linear direction. Okay, right. What else? This is the third one. This is something very interesting as well. So what do you think other than the magnitude and the direction, magnitude and the unit, what else we need? If there is a magnitude and if there is a unit, so we definitely need one more feature. What is that? One more feature. What is that? It's more than a feature. It is a requirement to test this idea. See what answers there in the group. People are good. There are so many nice answers. Savindya, numerical values. Yeah, most of the physical quantities, not the tangible idea. Hold a mass, no. That is physical objects. Right. My next question is, other than the magnitude and direction, other than the magnitude and SI unit, right? What else we need? What else we need? Sometimes the direction, yeah. Fundamental units, yeah, that's the unit we are talking about, right? Units, essential. Magnitude, and to measure the magnitude, we must have the unit. Yes. Other than the magnitude and the unit, there must be one more. There must be one more. What is it? So then we can come to the prefixes. Good idea. Bethany. The quantity is the magnitude. Bethany, quantity is the magnitude. Hansi, SI prefixes is part of the unit. If it is a measurement, I'll give you a hint. If it is a measurement, if you can measure it, to measure it, we need this. What is it? What do you think? Dimensions? Tool, very good, Francis, well done. Tool. We call these tools? We call these tools instruments. Very good, Nuha. Very good, well done. Instrument means tool. Tool, we need a tool. We need an instrument to measure it. Simple. Right? So why I wanted these parts to be clear before we start it, because when we have the magnitude, when we have the unit, we need an instrument to measure it. So remember, magnitude and the unit parties, they are in 1.2 and instruments, they are in 1.4. Very good. So that's how the lessons were developed nicely. That's how the lessons were developed nicely. Perfect idea. Right? So let's go for the screen and we try to go through this idea slowly. Physical quantities. Physical quantities are physical quantities. The smallest element of physics is physical quantity. Physical quantity is the quantity with a magnitude and well-defined unit to measure. The magnitude Examples. I have given few examples. You to go through it. Say weight, say 75 Newton. So you can see the component 75. You can see the component 75, right? So when you see this 75, here it is. 75 is the magnitude and Newton is the unit, and we have the device to measure the magnitude, right? And 3 centimeter, length of 3 centimeter, 3 is the magnitude, centimeter is the unit, and here you can see the devices such as meter ruler, pressure. We know that the pressure 5 Pascal, so 5 is the magnitude, Pascal is the unit, pressure gauge is the instrument to measure, volume 3 cubic meter, 3 is the magnitude, cubic meter is the unit, and the volumetric flask is, or Eureka flask or the volumetric flask is the instrument to measure it. Density 4 kilogram per cubic meter, and so this is a comparative idea. So how do you measure density? Little bit complicated. So sometimes you can use what? Hygrometers to measure density, physical quantities. Other than physical quantities, there are some non-physical quantities existence. Let's talk about that also. Before we go to that, I like to ask another question from you. Any other physical quantities comes to your mind? Any other physical quantities comes to your mind? Tell me, anything. Are you all in the WhatsApp group? So I like to see some comments in the WhatsApp group as well. Friction. We need the link in the WhatsApp group. Any panelist can send the link in the WhatsApp group. Seha, we'll send it. And I will tell you how to join the WhatsApp group as well. Our members will put the link, or either they will put the numbers to join the WhatsApp group. Luminous intensity, very good. Yes, Sandhu, very good. Zenith time, very good. Acceleration, I miss some. UMXX. I like you to have your name, good name. Akash, say friction, yes. Velocity, temperature. Sneha, velocity, temperature, electric current, very good. Generally, very good, well done. What else? Others who are there in the chat? So I like reading. So I'm a new student. I have been several. Thank you. The same. Yes, thank you. Pressure, kinetic energy, refractive index, amount of substance, yeah. Thermodynamic temperature, pressure, resistance, well done. Tashen, yes, I need answers. Percentages, no. Danuji, I'm asking about examples for physical quantities, not for non-physical quantities. Air resistance is a force, yes. Yes, and the energy, angles, very good. Okay, that's wonderful. Now let's go to the slide again. Yes, other than physical quantities, there are some physical quantities. Other than physical quantities, there are some non-physical quantities. So we call it non-physical quantity here, non-physical quantity. So what do you think non-physical quantities? What are they? Any non-physical quantities comes to your mind. Any non-physical quantities comes to your mind. Any non-physical quantities. I like you adding the discussion. Continue the discussion, because throughout next 2 years, it is about the discussion. So you talk to me, I give you questions, you chat. Don't let it feels like online, because sometimes, most of the time, people complain, sir, online class doesn't work for us. Don't think like that, because we are going to give you like the opportunities to communicate with us. The crew behind us, they are really working hard. So very sophisticated studio. So we can easily communicate with you. We have the chat open, we have the Zoom open, we have the smart board, we have the writing board, everything. So you just start communicating, because you can ask questions and clarify all the doubts. No, yes, we'll give the tudes. Of course, we are sending the tudes physically, and as well as we are uploading the PDFs. For now, right now, we don't want it. Very good. Yes, Sandhu Yonal. Very good. Love, beauty, happiness. Okay, let's start. Let's start from there. Let's start from there. Let's start from that point. Now, Yesandu brought up a wonderful idea. Emotions. Love. And what else? Emotions. Anger. Beauty. I'm asking a very simple question again from you. What do you think? Do they have magnitudes? Beauty. Beauty. Do we have magnitude for beauty? Can we define a magnitude for beauty? What do you think? Magnitude for beauty. නේද? ලස්සන කියන එකට විශාලත්වයක් තියනවද? ප්‍රමාණයක් තියනවද? තියනවද නැද්ද? තියනවද නැද්ද? හොඳට කල්පනා කරලා උත්තර දෙන්න. Love, do we have a magnitude for love? ආදරය කියන එකට විශාලත්වයක් තියනවද නැද්ද? තියනවද නැද්ද? Anger, කේන්තියට විශාලත්වයක් තියනවද නැද්ද? Do we have a magnitude for anger? Right? So, yes. Natalie. No. Are you sure? Why do you say no? Isn't it a doubtful answer? No. Why? Why say no? Why did you say no? Sometimes when you see something, someone, say, not something, someone, we say, he is beautiful. She is so beautiful. She is so beautiful. Yeah, mara lassanai. Walai bhashayen patta lassanai. What again? Vishalatwak thiyanawada නැද්ද? Is it a magnitude? Are we trying to convince a magnitude? Yes or no? What's your opinion? Isn't it a magnitude? Yes, it is. That's the important thing. It is a magnitude. The beauty, you can get in an idea or impression about the magnitude. True. What is missing in it? Not the magnitude. Then what? If it is not the magnitude missing, what is missing there? What is missing there? Tell me, what is missing there? It is, tell me, it is nothing other than the unit. You don't have a unit to tell how much beautiful, 100 something with a unit, 200 something with unit. So you can scale up. Scale like a you can beauty standard. So okay, tell me, how do you rate me for my beauty? 10 out of 10. Out of 10. How much? Out of 10, how much? 10 out of 10 or 9 out of 10 or 1 out of 10. Beauty, giving a comparative measurement, not absolute measurement, because we don't have a unit to measure it. Love. Now think about this example. You're getting a text message from someone, say your best friend. I love you. Just a text. I love you. That's it. What do you think? It's a lot of love or a little bit of love? what a message එකක් එනවා WhatsApp වලින් එනවා I love you only the 3 words that's it මොකද ආට හිතෙන්නේ එයා ගොඩක් ආදරේද ටිකක් ආදරේද you see your opinions in the chat what do you think if your friend says a little right Natalie says it's little because your friend doesn't say it like that doesn't it definitely no no clue okay so little bit of love I love you but if you want to convince the other person you love that person a lot how do you do that how do you do that how do you do that give me right Natalie wonderful that's how the Gen Z communicate isn't it I love you so many O's much and put some emojis hearts kisses yes then you communicate yes it is lot of love not a little bit right so is it a quantification what do you think is it a quantification are we quantifying the love are we quantifying the emotion are we quantifying the beauty is it a way to quantify the beauty it is kind of a way to quantify the beauty but the thing is it is not giving a proper idea about it why there is no proper idea because that quantification is not definite what is missing in it it doesn't matter how many O's you put into the text message text message කොහොමද type කරන්න කියන එක මත ඔයාට feel එකක් එන්නේ how much why what is missing no units very good Natalie is connecting a lot and interacting very much well done that's exactly we have to work now based on that so we can go ahead with the plan but the third one anger now your examples not my examples your examples beauty emotions love anger I'm angry with you is it a lot of that person has gone really mad another friend of yours say I'm angry with you I'm angry with you that's all you don't even care right you don't even care so anger you can quantify in a way to communicate the large you are really angry but you are less angry but you can't measure them exactly right so let's go to the screen again right so yes ratios relative densities refractive indices right refractive indices and relative atomic mass little bit scientific right little bit scientific right so numbers and values half where do we come across half half mv squared yes very good half mv squared 2f 2 pi 2 pi r na is Avogadro number Avogadro number 6.022 into 10 to the power 23 6.022 into 10 to the power 23 Quantity is related to mind and brain, anger, knowledge, love, etc. So those are not physically measurable quantities. We do not discuss in physics. But the first two, ratios, numbers and values, yes, we deal with them, but they're not physical quantities, right? But still we are dealing with them because, for an example, relative density. For an example, relative density, when you look at the relative density idea, relative density is, right? So relative density is, right, S, density of a material over density of water. Density of a material over density of water. Right? Density of a material over density of water. So density. So their units get cancelled, right? Their units get cancelled. Kilogram per cubic meter over kilogram per cubic meter. So no units there. So no units. So why they are in consideration? Because they are derived, they are formed by physical quantities. Even though they are not physical quantities, they are formed based on physical quantities. So we deal with them, those ratios as well. Yes. So there are two main types of physical quantities: fundamental physical quantities and derived physical quantities. So we are going to learn fundamental physical quantities. Fundamental physical quantity cannot be obtained using other physical quantities. That is the fundamental idea, but I don't like it much. I'll tell you why it is not. Why I don't like that much? The reason, honestly, remember, the fundamental physical quantities are fundamentals because, not because of a very special feature of it. Actually, SI system first defined not the quantity but the unit. If the unity is fundamental, then what happened? If the unity is fundamental, the physical quantity is a fundamental. So first of all, we need to understand what are the fundamental units. Fundamental units are the units defined based on real world unique events or values, constants. We come to that in the next couple of slides, right? Next couple of slides. You're getting the full note. You're getting the full note, the PDF, as well as you're getting the full note of what? You're getting the full note of this hard copies. You're getting it delivered. These people handling it. Honestly, we are going to do this for you guys who are joining the free session today. Every one of you getting the tube delivered to your home address. So remember to join the WhatsApp group and send your home addresses in the WhatsApp group or in our hotline or here in our chat. So you get it delivered to your home address. Okay. So that's a free delivery. You're getting it free, even you're registered to the class or not. It is the first day offer. So only for this week, you are getting it absolutely free. When you're coming next week, you can bring the hard copy, keep the hard copy with you. So then you can go through all these notes. You don't have to worry about writing notes. We are giving everything what you want to do here, work here, right? Okay. So let's go for that, the idea a little bit seriously. There are 7 fundamental physical quantities. There are 7 fundamental physical quantities. Length, mass, time, thermodynamic temperature, amount of substance, electric current. I want you to refer these 7 one by one. Length, mass, time, thermodynamic temperature, amount of substance, electric current, luminous intensity. I want you to go through them. Take your time, read it one by one again and again. By heart this 7 in next 2 minutes. I want you to by heart them in next 2 minutes. Sneha, Seha, yes, it is a ratio. It is a ratio with a unit. It is a ratio with no unit. Hakshara, so you have to drop your phone number, the details we have mentioned there, or either join the group and make the request there. So this is 2 minutes. You to study these 7 in order, one by one. Okay, so hope you studied all 7. Can we dictate it? Even you are not in the class, experience the perfect class environment, staying in your house, in your study room, in your uh, lobby, or wherever it is, bedroom, or wherever it is, not in the kitchen for sure, right? So I want you to pronounce or dictate this with me, right? Okay, tell this. Length, mass, time, thermodynamic temperature, amount of substance, electric current, luminous intensity. One more time. Length, mass, time, thermodynamic temperature, amount of substance, electric current, luminous intensity. Now, you do it without checking this board screen, and do it one more time by yourself, for yourself. Right, done. If you are confident about those 7, yes, we can go to the next part. Now my question is, how do you recognize length is a fundamental physical quantity? It is based on their fundamental units. Okay, it's based on their fundamental units. Fundamental unit, keep it in your mind, fundamental unit are perfectly defined, complicated manner. So those definitions are irrespective of the combination of the other units, right? So there are 7 fundamentals, right? Let's see how they have defined. I'm asking a very simple question from you again. Now, what is the first fundamental unit? What is the fundamental unit of length? What is the fundamental unit of length? What's the fundamental unit of length? I need answers there. I need answers there. In the group, in the WhatsApp chat. Safia, I like Yasindu, Yonal's answer. Senuti also better. Natalie, there's a small mistake. You know what it is? Meters. Okay, let's talk like this. Start like this. Now tell me, what is the meaning of the word unit? U-N-I-T, unit. What's the meaning of it? What's the meaning of it? What's the meaning of it? What's the meaning of unit? What's the meaning of unit? What's the meaning of unit? Unit. I'm asking unit, nothing to do with the physical quantities, not meters, anything like that. Unit. What's the meaning of unit? Unit කියන්නේ මොකක්ද? Nothing, no science. Unit. Very good. Bethany, very good. Well done. Singular. 1. Francis, well done. Very good. Dinura, Akash, no. Sahla, Jeffrey, yes. Perfect. Unity is 1. That's it. 1. Whatever 1 is unit. Unity as 1. United Nations, all the nations united together. What is not practically happening there, that is a different story. But United Nation, entire the world, all the nations are united as one. United States of America, all 50 states of America united together and one state, that is United States of America. United Kingdom, the entire kingdom united together one as one, that is united, unity, one unit. Unity is 1. So therefore you can't pronounce it like meters. Unit of length is 1 meter. Unit of time is 1 second. Unit of mass is 1 kilogram. Unit of thermodynamic temperature is 1 Kelvin, like that. Hope you understand. Right? But the problem is, how much this 1 meter is? Unit of length is 1 meter. That is very clear. No doubt, no problem at all. My question is, what is it? So how do you know how much 1 meter is? How much 1 meter is? Anyone of you know how much 1 meter is? How much 1 meter is? What do you think? How much 1 meter is? That is interesting. How much 1 meter is? 1 meter is, that is quite interesting. 1 meter is. Can I tell you? No, not 100 centimeters. Because then I have a question. So what is 1 centimeter? So you have to say 1 meter and divide to 100. So to divide into 100, you should know what is 1 meter. So what is 1 meter? 1 meter is the distance traveled by light. Distance traveled by light in vacuum. Distance traveled by light in vacuum during a time period of 1 over 299,792,458 times of a second. That particular distance is 1 meter. Distance traveled by light in vacuum during a time duration of 1 over 299,792,458 times of a second is 1 meter. That is 1 meter. Complicated. What is that value? 299,792,458. What is that value? That value is the speed of light in vacuum. So it's a reverse kind of a definition. Using the speed of light in vacuum. Using speed of light in vacuum. Interesting. Speed of light in vacuum. Right. So that's how the values are defined. Now you understand 1 meter is defined using a universal constant called speed of light in vacuum. That definition, those are the fundamentals. Those are the fundamentals here. Those are the fundamentals. These fundamental physical quantities are taken. These fundamental physical quantities are taken by comprehensive definitions using universal constants. That's how they are fundamental units. They are fundamental units. Fundamental units used to measure some quantity. That quantity is a fundamental physical quantity. Hope you understand the concept very clearly. Right? Any doubts? Any questions? Right, very good. Safia, I told you, right? 100 centimeter is not the answer. Why 100 centimeter is not the answer? 100 centimeter, to get 100, to divide this into 100 pieces, you should know what is 1 meter first. Otherwise, you can't divide it into 100 pieces. Nice, Natalie. And the others. I like others helping me, giving me little bit an opinion. I want to see. So people who understand, please respond. I like to have a response. Very good. Safia, no. Luckily. Now that's the wrong question and right question there. So do we have to know the definition of it? Do we have to know for what? Now let me, I mean, this is going to be a small lecture. ඔගොල්ලෝ ආස නැති එක නිකන් පොඩ්ඩක් පොඩි lecture එකක් ඔයගලන්ට. ඒ කියන්නේ ඔයගොල්ලෝ do we need to remember them no by heart? No need, definitely. Why? Because all these definitions are there in websites. You know, you can go to Google, Gemini, ChatGPT. You can ask the questions and you can get these definitions done. So you don't have to by heart anyway. But you ask, do we need to know them? Yeah, it's better, because while you are learning, you learn to know things, right? That is the very first point of understanding this subject. So to understand what this is and all, we need to know them. Yes. As a physics student, as a physicist, one day you're going to be, as a doctor, engineer, who are going to be a science person in the future, you should know what the definition is. But I don't want you to by heart anything. By hearting is not knowing it. You should know, like, okay, this is how they define, this is defined. But very important questions he asks. Indirectly, she's implying, so do we need to by heart this for the exams? Definitely no. But learning is not always about exams. Try your best to understand, try your best to learn. Yeah. So when you learn things, you know things. When you know things, you feel better, you feel good, and you feel you're a genius, right? So later you are writing exam, what component to write, what not to write. Yes, we will see it in the future, right? Yes. And our staff have added this, the lesson as well. the answer for that. We are having some videos and all. So we'll see why it is. I mean, that's a good point. අර මං කියපු එකට හොඳ එකක්. ඒ කියන්නේ මේවා දැනගෙන ඉන්නනේ අපි අහන්නේ. ඒවා විභාගෙට අහන්නේ. අහන එක අපිට සිලබස් එකේ තියෙන එකක් නෙමෙයි. නමුත් මම කියන ඒවත් අපි දැනගෙන ඉන්න ඕනේ කියන්නේ අපිට කියලා දීලා තියෙන්නේ ඔයාලට ෆන්ඩමෙන්ටල් යුනිට්ස් උගන්වන්න. කොහොමද උගන්වන්නේ? කොච්චරක් උගන්වන්නද? එහෙම අපිට මුකුත් කියන්නේ නැහැ ඒගොල්ලෝ. මොකද මේක advanced level. Advanced level is little bit advanced than O level. So you are not by hearting stuff and you are going to the exam. You learn only the part what you need to know. The exam's wrong. Because we have to explore you. We have to make the curiosity to understand. Now I like that Francis asking a question. So how they have known that exact, that specific value? That is, I will tell you something very interesting about it. We have some videos to watch. We'll watch in a while, right? Right. So since he's interested.
French Revolution have to do with the time NASA accidentally crashed a $200 million orbiter into the surface of Mars. Actually, everything. That crash happened due to an error in converting between two measurement systems, US customary units and their SI or metric equivalents. So what's the connection to the French Revolution? Let's explain. For the majority of recorded human history, units like the weight of a grain or the length of a hand weren't exact and varied from place to place. And different regions didn't just use varying measurements, they had completely different number systems as well. By the late Middle Ages, the Hindu-Arabic decimal system mostly replaced Roman numerals and fractions in Europe. But efforts by scholars like John Wilkins to promote standard decimal-based measures were less successful. With 250,000 different units in France alone, any widespread change would require massive disruption. And in 1789, that disruption came. The leaders of the French Revolution didn't just overthrow the monarchy. They sought to completely transform society according to the rational principles of the Enlightenment. When the new government took power, the Academy of Sciences convened to reform the system of measurements. Old standards based on arbitrary authority or local traditions were replaced with mathematical and natural relationships. For example, the meter, from the Greek word for measure, was defined as 1/10,000,000th between the equator and North Pole. And the new metric system was, in the words of the Marquis de Condorcet, for all people, for all time. Standardizing measurements had political advantages for the revolutionaries as well. Nobles could no longer manipulate local units to extract more rent from commoners, while the government could collect taxes more efficiently. And switching to a new republican calendar with 10-day weeks reduced church power by eliminating Sundays. Adoption of this new system wasn't easy. In fact, it was a bit of a mess. At first, people used new units alongside old ones, and the republican calendar was eventually abandoned. When Napoleon Bonaparte took power, he allowed small businesses to use traditional measurements, redefined in metric terms. But the metric system remained standard for formal use, and it spread across the continent along with France's borders. While Napoleon's empire lasted 8 years, its legacy endured far longer. Some European countries reverted to old measurements upon independence. Others realized the value of standardization in an age of international trade. After Portugal and the Netherlands switched to metric voluntarily, other nations followed, with colonial empires spreading the system around the world. As France's main rival, Britain had resisted revolutionary ideas and retained its traditional units. But over the next 2 centuries, the British Empire slowly transitioned, first approving the metric system as an optional alternative before gradually making it official. However, this switch came too late for 13 former colonies that had already gained independence. The United States of America stuck with the English units of its colonial past, and today remains one of only 3 countries which haven't fully embraced the metric system. Despite constant initiatives for metrication, many Americans consider units like feet and pounds more intuitive. And ironically, some regard the once revolutionary metric system as a symbol of global conformity. Nevertheless, the metric system is almost universally used in science and medicine. and it continues to evolve according to its original principles. For a long time, standard units were actually defined by carefully maintained physical prototypes. But thanks to improving technology and precision, these objects with limited access and unreliable longevity are now being replaced with standards based on universal constants, like the speed of light. Consistent measurements are such an integral part of our daily lives that it's hard to appreciate what a major accomplishment for humanity they've been. And just as it arose from a political revolution, the metric system remains crucial for the scientific revolutions to come.
Right? So, it is interesting, isn't it? So, did you go through the full video? Were you listening? That is interesting to add that part with the idea of what Francis asked. What is it? Now get this idea clearly. Why they have defined such thing in a very complicated manner. They should have done 3,000, 5,000, 3 million, 30 million, 300 million, something like that. So why not? Why not that way? Right? Why not that way? So think about this. What happened? Did you notice there's something very interesting they said? What was it? Initially they have taken a distance, right? Initially they have taken a distance from the North Pole to the equator and divided into a nice value. Say 1 million, no 1 billion or something. In a way, it is little bit creepy. The scientists get together and they decided some sort of a value. Some sort of a value. That has come from ancient standards. They did not change it completely. So North Pole to the equator, say that distance divided into billion parts for an example. Now we have a figure. We have a size already. We know this is 1 meter. Now we wanted to define this 1 meter rather part of a stick. I will show you in another image the stick here, right? So let me bring
I grew up in
you here. This one, right? This one, this what you see, what you see here, right? What you see here. What you see here. Now this you can see there was a long metallic stick, right? Long metallic stick. So here. So with a creepy cross-sectional shape. This metallic stick was the standard 1 meter those days. Think about it. Standard 1 meter is this. They had a metal stick made from platinum iridium and they cut that length and kept that there in France National Museum of Metric Systems. And whenever you want to take a measurement, take 1 meter, there is only one meter there in the history. It's a physical measurement. Then again, 1 meter eva godak tibila naha ekai. Mokadda meka. Meka thamai 1 meter එක. Meka thamai history එකේ තිබිච්ච 1 meter එක. If I'm not mistaken, 1 meter, this one was removed. This one was removed 1983. මම history එක මෙච්චර මතක තියාගෙන ඉන්නේ නැහැ. හරිද? history එකේ මෙච්චර මතක තියාගෙන ඉන්නේ නැහැ. නමුත් නිකන් ලාවට මතකයි. දැන් අර මම හිතන්නේ සෆියා හුවනේ question එකක් සෆියා හුවා මගෙන් මේව මතක තියාගන්න ඕනේද? Do we need to remember this? දැන් සමහර ඒවා අපි නිකන් ඔහේ on the go remember නිකන් මතක තියාගෙන ඉන්නවා. එහෙන් පාඩම් කරන්න ඕනේ නැහැ. මම මේ සමහර data කියනකොට data හරියට මතක තියාගෙන හරියගේ කියන්න බගලන්න ඕනේ නැහැ. ඒක පොඩ්ඩක් එහාම යනකොට ප්‍රශ්නයක් නැහැ. ඔයාට ඉන්ටර්නෙට් එකේ ගියාම මේක හොයාගන්න පුළුවන්. මේ 1 meter, this 1 meter was removed 1983. Right? 1983. It was good, isn't it? එතකල් ඔන්න ඔය metal piece එක තමයි. මෙන්න මෙහෙම යකඩ කෑල්ලක්, යකඩ පොල්ලක්. ඒගොල්ලෝ කියවා 1 meter කියලා. ඒක ආවේ කොහොමද? අර ancient story එකෙන් ඉඳන්. Ancient story එකේ ඉඳන් ඒ දිග අරගෙන proper number එකකට කැපුවා. හැබැයි ඒ දිග යුනිට් නෑ. ඒ දිග වෙනස් වෙනවා. So we wanted to go for Francis' question. We wanted to go for a proper definition which is not changing time to time. දැන් යා මොකද කරේ? දැන් ලයිට් එක යවුවා. ලයිට් එක වැකියුම් එකේ අර වගේ පොළු කෑලි these metallic rods කොච්චරක් යනවද? 299,792,458 times යනවා. දැන් reverse definition එකක් ගත්තා. එතකොට ඒක ඔයාලට control කරන්න බෑනේ. Francis, do you understand my point? That you can't control because you already have a metal stick. So මේ metal stick එක වගේ 299,792,458 times light එක යනවා නම් අන්න ඒ distance එක අරන් reversely define කරා. So okay, for 1 second it goes that distance. On the other hand, we define it like this. So the distance travel, reverse definition, distance travel in 1/299,792 times, for 299,792,450 times of a second, 1/, is 1 meter. Hope you all perfectly understood the concept of defining SI units fundamental. Understood? Now you can ask questions, and we're going to watch another device that is called 1 kilogram. මේක ගැන පොඩි කතාවක් තියෙනවා, ඒකත් කියලා ඉන්නද? මේක ගැන පොඩි කතාවක් තියෙනවා කියලා ඉන්නම් මම ඔයගලන්ට. මේ තියෙන්නේ 1 kilogram එක. පොඩ්ඩක් පේනවා මදි ඇති. අපි තව චුට්ටකින් හරියටම පෙන්නමු. එතකල් ඔයා නිකන් බලන්න. මේ තියෙන්නේ 1 kilogram එක. ඔයාලට පේනවද මෙන්න මෙතන තියෙනවා පොඩි මෙන්න මෙතන තියෙනවා පොඩි මෙටල් කෑල්ලක් මේ තියෙන්නේ. මෙන්න මේ මෙටල් පීස් එක. ඒ මෙටල් පීස් එක මෙන්න චක්‍ර මෙටල් පීස් එකක්. So that is made from platinum iridium again, because they are very long lasting metals, no decay. මෙන්න මේ මෙටල් එක කවර්ස් 3කින් විතර වහලා තින්නේ. අපිට පේනවද මෙතන මේ කවර්ස් 3ක් විතර තියෙනවා. ඒ කවර්ස් වලින් වහලා තින්නේ. ඒතර ඒවා ප්‍රොටෙක්ට් කරලා තියලා තිනවා. හරිද? That is the sample. Again, where is it? Paris in France, National Museum of Metric Systems. So they agreed to consider this as 1 kilogram. Now, even the resource book does not mention this properly. Okay, trust me. O-level potaram poda balannako, A-level potaram balannako, මේවයි definitions නැහැ. Unfortunately, they are wrong. I mean, දාලා නැහැ. මොකද මම කියන්නේ 2018 there was a change of the definition. මේ very recent past. 2 years back before Corona. So they changed the definition of 1 kilogram. They changed the definition of 1 kilogram. Very interestingly, we have added it and our notes we have it. But remember, even the resource book did not change it yet. It is 26 CGPM. Right. 13th to 16th November 2008. Right. Yeah, you can see that 26 CGPM, 13 to 16 November 2018. Right. 2018. Very good.
I grew up in the United States, which means I used pounds and ounces to measure everything that I used growing up, except maybe soda bottles. Right, and I grew up in the UK where I grew up in the United States, which means I used pounds and ounces to measure everything that I used growing up, except maybe soda bottles. Right, and I grew up in the UK where I use the metric system for pretty much everything, and pounds are what I pay for things in the store with. So while we don't really agree on a unit of measurement yet, there is one thing that everyone should be familiar with, and that's the kilogram. Right, and not just because it's a superior unit of measurement or because it's used pretty much everywhere in the world, but because it recently changed. How much does a kilogram weigh? This is not a trick question. When the kilogram was first introduced as a unit of mass in the 18th century, it was decreed to be the absolute weight of a volume of pure water equal to the cube of the 100th part of the meter. Basically 1 cubic decimeter or 1 liter. About this much. Anyway, the French scientists who came up with this definition soon discovered it was a little sloppy. The weight of the water changes depending on things like purity and atmospheric pressure, so they replaced that definition with something like this. For more than 100 years, a metal artifact similar to this has been the definition of the kilogram. The real one is made of platinum iridium, and it's called the International Prototype Kilogram. Since 1889, it's been kept under lock and key in a vault on the outskirts of Paris. The prototype kilogram has been a big deal. Think about it. If we didn't have reliable units of weight, how would countries trade? How would scientists repeat experiments and share their results? How could you trust a recipe or even your bathroom scales? That little chunk of metal is the foundation of the modern world. But recently, scientists voted to get rid of it, and they replaced it with something far, far stranger.
Last month, I visited the headquarters of the International Bureau of Weights and Measures in France, the body that acts as the guardian of the metric system. And I watched as delegates from 60 countries voted to retire the prototype kilogram. It was amazing to see, each country standing up to vote one by one, and then the whole hall erupts into applause and congratulations. For some of the scientists there, it was the culmination of a lifetime of work, slimming down the world's system of measurement so that all the definitions now fit onto a single card.
But before we get into that, let's think about how weights work in general. We know that the prototype kilogram and its successor define standards of weights around the world. But if you grab some scales and weigh out a kilogram of flour, how do those scales know how much a kilogram weighs? Well, we called some scale companies to find out.
Hello, how may I help you?
Can you tell me how you go about calibrating your scales? How do you make sure that they're accurate?
Here's what we learned. Basically, a scales company like Ascali buys calibration weights to place on their scales and dial them in. A weight like this one was measured against an even more accurate kilogram, which itself might be measured against an even more accurate kilogram, all the way up the ladder of accuracy until, in the US anyways, it reaches the National Institute of Standards and Technology. They have a couple of very special artifacts. 2 of the 40 original weights that were measured directly against the International Prototype Kilogram in 1889.
And they numbered them from 1 to 40, and they screwed one number up, and they left out 8 and numbered it 41 by mistake. That's a little detail.
That's Stefan Schlaminger, a physicist at NIST. He says there was a global raffle for countries to get the 40 original weights.
And the United States got 2, number 4 and number 20.
Today there are more than just 40. New ones are measured against a final ultra-accurate stand-in for the IPK called the working standard.
The working standard is basically used to calibrate now all masses from all nations.
That's how things used to work. But with the redefinition last month, instead of tracing weights back to the prototype kilogram, there's a new top boss. The kilogram is no longer a lump of metal. It's a constant of nature. The kilogram isn't the first unit to go through this change. In fact, it's the last. The meter, for example, was once defined as 1/10,000,000th of the distance from the North Pole to the equator, a length that was enshrined in a physical artifact. Now it's defined as the distance that light travels in a tiny fraction of a second, about a 300 millionth. The kilogram, on the other hand, is now tied to the smallest action that can be made by a photon, which is essentially the smallest possible physical action there is. It's called Planck's constant, and in order to tie mass to it, scientists had to create one of these, a Kibble balance. It works like an old-fashioned balance beam, but instead of weighing one mass against another, it weighs one mass against an electromagnetic force. This force can be measured with extreme precision using Planck's constant, and this will be the new definition of the kilogram.
But look, there's one question we've not talked about so far. Why? Why are we going to all this trouble? Well, when I spoke to the scientists at the big vote last month, they gave me 2 reasons. First, accuracy. The problem with using a physical standard to define the kilogram is that physical objects change. None of them last forever, and over the past few decades, the prototype kilogram itself has lost mass. Not much, about 50 micrograms or the weight of a human eyelash, but still, thanks to that huge chain of calibrations we traced, technically every kilogram in the world ends up shifting by 1 eyelash weight. Not ideal. But more importantly, they said it was about ideology. The prototype kilogram is based in France because it was created during the French Revolution. This was a time when revolutionaries were tearing down and reconstructing so many of society's norms, and that included weights and measurements. They wanted to make units that were consistent, that were fair to the working man and woman, and that was shared between countries. They wanted to unite the world. Their motto was pour tous les temps, pour tous les peuples. For all time, for all people. But if we define mass using a single prototype kilogram locked away in a basement in France, then it can't be for all men and for all women. And if it changes when we measure it, it can't be for all time. So the scientists say by tying the kilogram to a constant of nature, we are in a way freeing it from its physical constraints. We're achieving the dream of the creators of the metric system, a journey that's been centuries in the making.
Planck's constant is something that's woven into the fabric of the universe, so everybody can access it, and I think that opens a whole world.
Sync it up. Okay.
I usually keep these, the YouTubers' names and all. Why is that? Now you need to understand, very simple. Now we are living in a technological world, right? So now we are presenting, now we are giving this entire online thing at a different level. So that's one reason you need to learn online from Online Mahagedara, right? SyZyGy Online Mahagedara. That is a next level work with the technology wise. For you guys living in the social media generation. So I keep all these YouTubers details because I'm not asking you to go to YouTube always to learn, but they're fun. They're interesting. So when you watch 1 or 2 videos, you definitely, what will happen? Algorithm will do the rest. So they will suggest some interesting more videos from these guys, and their science creeps. They do some innovative stuff, very interesting videos. Every day I bring out these kind of videos to you guys, not only to show you the video, because I know that you can search online and find the video, but you never do. So, do you? Right? So what my request is, join with us. Even in our social media, I'm available in all sort of social media, right? Facebook, TikTok, Instagram, YouTube, Snapchat, WhatsApp, whatever you call, we are there, right? So join with us because we are sharing a lot of videos and a lot of links. Then you can subscribe. So then they will suggest more scientific stuff. It is not only about learning, 7:30 to 10:30 in the night, Friday, physics. You can't learn and finish it because you can watch, you can read a lot there. So understand the point. It is not boring. The science is not boring. Physics especially not boring at all. Physics is a very interesting subject. If you keep listening to these things, now you have seen the science professor. He is a professor. He is not just a professor. He is a professor of the world forums. He is a part of that, changing the definition of 1 kilogram. And they're having a tattoo. They're having a tattoo. He's having a tattoo on his hand. But scientific constant, Planck constant, because they changed the definition. It's a world forum to decide what definition to use. Now you guys understand why these definitions are comprehensive and how the standards are made. You saw 26th conference, perfect real conference. They one by one stand and name by name, Sri Lanka, Canada, Ethiopia. So they all have to agree. That is what we call Standard International. Standard International is not just a system. It is a community. We all are community. We all are connected together with that international system because that is important. You have seen the first video I showed, the French Revolution. Some satellites crashing the orbits of the sun. No, orbits of the moon, sorry. So we do these things, right? So you go to the YouTube, you go to Insta, you watch fun stuff. Yes, this is also part of your journey for next 2 years. So definitely what you're supposed to do, I want you to subscribe these channels, join our communities, our social media channels, and then you learn through this, the interesting forums, right? Okay. Now you have seen that. And so I can define 1 or 2 for you. You guys, that this is the one simple idea. Kilogram is connected to H is the Planck constant. 1 meter is connected to C. C is speed of light. speed of light. Second, okay, let's take the second. I'll define the second here. Second, 1 second. How do you define 1 second? Creepy definition again, huh? Don't get upset and don't ask me, sir, do we need to remember this? No, you don't have to remember that. I just remember things because we were working for so long in this industry and I was teaching this for a long time. So it was there in my mind. I used to study and remember because it is interesting and funny at the time, right? So what is the definition of 1 second? The time duration, 9,192,000,000 9,192,631,770 times of time period associated with the energy transition of cesium 133 atom super hyperfine energy levels. Complicated, isn't it? Complicated. So I remember, but you don't have to by heart, but you need to know at least that is how we define 1 second. Isn't it good to know? Yes, of course. Right? So these are the definitions. You can see the definitions there on the screen. So I will share the screen for you. And yes, so you can just go through it. And these definitions I have not included into the tude because you don't have to study and by heart them. But if you want, we are anyway sharing these videos and the slides and PDFs and all in the groups also. You can study them. You can go through them. You understand them. That is no harm for you, right? And now you can see international system of SI unit fundamentals are taken into one single card based on the constants in the right hand side. Definitions are there at the middle. Base unit names are there, and it is how it is. Now 7 fundamental physical quantities are defined like that. Okay, so let's before we go to the derived units, I will tell you what this is. Basically, these are the light meters. Light meters. Why I have added light meters? Because we have candela there. So you can see these meters, they consist old models and new models. So where do you use light meters? Where do we use light meters? We use light meters in 2 cases. Now even these studios are made with light. So they want to test whether like my face looks good with the camera. So what do? They set up the light meters with the exact candela values. And in case if you have noticed, people who watch cricket, sometimes the test matches, they check whether it's a bad light. So they keep the light meters. In movies, in Hollywood, Bollywood, so when they set up the set, when the actress and actor came to the scene, they check the light onto the face to see whether that is the vibe they need to create in the movie. Because you have seen some movies are very gloomy. Some movies are very colorful. Can you tell me like proper 2 popular examples from the last year? Oppenheimer. And from the other side, what is it? Barbie. Right? So 2 different color vibes. So that is set by the light meters. These are the light meters, measures candela, the light intensity. Unit of candela. Unit is candela for the light intensity. So this is how they are done. Okay, so so first session is completely over. So we completed the fundamental SI system of unit, fundamental physical quantities, and the second session will be from the derived units and derived physical quantities as well as the supplementary units. So we'll learn that part after a short break. So don't take a long break. You're staying at home. It's not very tiring. So you can quickly stand up and go around and have a cup of water, go to the washroom, wash your face, and come back in 5 minutes. It's just a 5 minutes break.
දකින්න හීන දකින්න ඔබගේමයි පියාඹන්න නැහැ බාධා දකින්න හීන දකින්න ආයෙත් නැහැ බාධා ගමේ නගරයේ කන්දේ තැනිතලාවේ
හීන දකින්න ආයෙත් නැහැ බාධා
අඳුරේ
SyZyGy Online මහගෙදර.
ගුරුවරුන්ගෙන් හොඳම තාක්ෂණයෙන් ඉගෙන ගන්න SyZyGy Online මහගෙදර සිංහල සහ ඉංග්‍රීසි මාධ්‍යයෙන් උසස් පෙළ සියලු විෂයන්වල පන්ති දැන් ඔබේ නිවසටම කම්බයින් මැත්ස් දුෂ්‍යන්ත මහබදුගේ කෙමිස්ට්‍රි චරිත දිසානායක ෆිසික්ස් සමිත රත්නායක බයොලොජි චරිත මුණසිංහ
English Medium Science Combined Maths Dushyanta Mahabaduke Biology Chartha Munasinghe Physics Janithu Leelananda Physics Sanjeewa Dharmawardhana Chemistry Nirandika Jayawardhana
Accounting Hemal Pereira Business Studies Charaka Dhananjaya Economics Kumar Bagasinghe Economics Lucky Chaturanga Agriculture Science Dinesh Atukorala ICT Lasita Prasad SFT Sadun Priyankara ET UD Madhusank Saha Tulanj Rusiru BST Dinesh Atukorala Sinhala Sujeewa Sirimewan Media Asela Bandaranayaka Political Science Nilu Tennakon Geography Ruwanmali Jai Vikrama History Chandima Vijay Bandara History Anusha Liyanage Logic Hiruni Hevage වැඩි විස්තර සඳහා පිවිසෙන්න www.syzygyonline.lk අමතන්න 0770යි 702යි 702 SyZyGy Online මහගෙදර හොඳම ගුරුවරුන්ගෙන් හොඳම තාක්ෂණයෙන් ඉගෙන ගන්න SyZyGy Online මහගෙදර සිංහල සහ ඉංග්‍රීසි මාධ්‍යයෙන් උසස් පෙළ සියලු විෂයන්වල පන්ති දැන් ඔබේ නිවසටම කම්බයින් මැත්ස් දුෂ්‍යන්ත මහබදුගේ කෙමිස්ට්‍රි චරිත දිසානායක ෆිසික්ස් සමිත රත්නායක බයොලොජි චරිත මුණසිංහ
English Medium Science Combined
කාලය වේගයෙන් ගලා ගියා. තාක්ෂණය ලෝකය වෙනස් කළා. හෙටලොව කෙබඳු වුවද
Sanjeewa Dharmawardhana Chemistry Nirandika Jayawardhana
Accounting Hemal Pereira Business Studies Charaka Dhananjaya Economics Kumar Bagasinghe Economics Lucky Chaturanga Agriculture Science Dinesh Atukorala ICT Lasita Prasad SFT Sadun Priyankara ET UD Madhusank Saha Tulanj Rusiru BST Dinesh Atukorala Sinhala Sujeewa Sirimewan Media Asela Bandaranayaka Political Science Nilu Tennakon Geography Ruwanmali Jai Vikrama History Chandima Vijay Bandara History Anusha Liyanage Logic Hiruni Hevage වැඩි විස්තර සඳහා පිවිසෙන්න www.syzygyonline.lk අමතන්න
කොරෝනා වසංගතය හමුවේ රටේම දරුවන්ගේ අධ්‍යාපනය බිඳ වැටෙන්න නොදී මෙරටට ඔන්ලයින් අධ්‍යාපනය හඳුන්වා දුන් සැබෑ පුරෝගාමියා. ඔහු සංයුක්ත ගණිතයේ නොම්බර 1 දුෂ්‍යන්ත මහබදුගේ. මෙවර ඔහු ඔන්ලයින් අධ්‍යාපනයේ තවත් විප්ලවීය වෙනසක් සිදු කරමින් SyZyGy Online මහගෙදර ඔබ වෙත තිළින කරයි.
ආයුබෝවන් දුවේ පුතේ. ගොඩක් අය හිතන්නේ ඔන්ලයින් පන්තියක් කියන්නේ පන්තියක උගන්වන එක වීඩියෝ කරලා දාන එක හරි වයිට් බෝඩ් එකක් ඉස්සරහා ඉඳන් කරන එක හරි කියලා. නෑ, ඒක වැරදි. මම මගේ SyZyGy Online මහගෙදර නිර්මාණය කළේ ජාත්‍යන්තර ප්‍රමිතියකට. මෙතන තියෙන්නේ නිකම්ම ස්ටුඩියෝ එකක් නෙමෙයි. බලන්න මේ ලයිට් බෝඩ් එක දිහා. මම ගණිත ගැටලුවක් විසඳනකොට මම ඔයාලා දිහා බලාගෙන ඒ දේ කරනවා. ඔයාලට මගේ ඇස් දෙක පේනවා. මගේ හැඟීම් පේනවා. ඒ විතරක් නෙමෙයි. ස්මාර්ට් බෝඩ් එක, රයිටින් පෑඩ් එක, තාක්ෂණ නිසා සංකීර්ණ රූප සටහන් වුණත් ඔයාලගේ ඇස් ඉස්සරහාම ජීවමාන වෙනවා. මම මේ හැමදේම කරන්නේ ඔයාලට මේ විෂය එපා නොවි හරි ආසාවෙන් ඒකකට යන්න පාර හදන්න. මම හිතන්නේ දුවෙක් ප්‍රශ්නයක් යොමු කරලා තියෙනවා. ඒ දරුවා අහනවා මේ ගුරුත්වය යටතේ චලිතයක් වෙනුවෙන් අදහස් කරන්නේ කුමක්ද කියලා. ගුරුත්වය යටතේ චලිතයක් කියලා අදහස් කරන්නේ බර යටතේ පමණක් සිද්ධ වන චලිතයක්. අපි දන්න ඕනෑම වස්තුවක ගුරුත්ව කේන්ද්‍රය හරහා සිරස්ව පහළට බර ක්‍රියාත්මක වෙනවා.
ඔහු මේ වෙනුවෙන්ම ඉදි කළ අති දියුණු තාක්ෂණික මෙවලම් වලින් සන්නද්ධ ස්ටුඩියෝ සංකීර්ණය හරහා ඔබට වෙනත් කිසිදු ඔන්ලයින් පන්තියකදී නොලැබෙන සුවිශේෂී පහසුකමක් සහ පැහැදිලි බවක් ඉගෙනුම් ක්‍රියාවලියේදී ලැබෙනවා.
තාක්ෂණය කියන්නේ බාධාවක් නෙවෙයි. ඒක ජයග්‍රහණයට යන කෙටි පාරක්. එන්න සංයුක්ත ගණිතයේ අති නවීන අත්දැකීම විඳ ගන්න. SyZyGy Online මහ ගෙදරට එකතු වන්න.
පියාඹන්න නැහැ බාධා. දකින්න හීන දකින්න ආයෙත් නැහැ බාධා. ගමේ නගරයේ කන්දේ තැනිතලාවේ
හීන දකින්න ආයෙත් නැහැ බාධා.
අඳුරේ
SyZyGy Online මහගෙදර.
In the first session, fundamental physical quantities. That's the basic. And I have added all of you to the WhatsApp groups, and we can chat there as well. You can drop the questions there as well, answers there as well. So my question now, what is a derived physical quantity? How do you recognize what is derived, what is fundamental? Now for me, I have developed a formula to understand what's a derived physical quantity. Derived physical quantity, right? Let's go to the slides and see. Either the fundamental, you connect fundamental physical quantities and fundamental physical quantities. So you understand it as the derived physical quantity. Other than fundamental and fundamental, we can develop what? Fundamental and derived physical quantities. Fundamental and derived physical quantities. And derived physical quantities. Right? So let's take this. Let's take some examples of it. The first category, right? So fundamental and fundamental. So you know that basically you have seen velocity, displacement over time. What do you think? Displacement over time. What is this? Displacement. Displacement is a fundamental physical quantity, length. This is time. Time is a fundamental physical quantity. So this is a time, fundamental. This is a fundamental. Right? So this is also fundamental. Right? And this is a derived physical quantity, velocity. And fundamental can create a derived physical quantity. Let me go for another popular formula. You guys know F equals ma. F equals ma. So here, this is a fundamental, and we give a fundamental here, and this is a derived here. What do you think? This is derived, and this is fundamental. And derive and fundamental produce what? Derive and fundamental produce what? Derive physical quantity. Derive physical quantity. And pressure. Pressure equals force over area. Force over area. Right? Now we know that force is what? A derived physical quantity. So this is a derived physical quantity. And this area is a derived physical quantity. So we have derive and derive. Derived physical quantity and derived physical quantity is creating us a derived physical quantity. Right? So let's take a few more. So what is this? This is pressure. This is pressure. Right? Pressure. And this is force. Force. And this is area. Right? And derive, creating a derived physical quantity. Here derive, this is acceleration. Acceleration. Right? And it is a derived physical quantity. And this is what? Fundamental physical quantity, that is mass. Fundamental physical quantity. Force is a derived physical quantity, that is force. Derived physical quantity created by fundamental and derived physical quantity. On the other side, right? On the other side, so velocity equals displacement over time. Time is a fundamental and fundamental creating what? Derived physical quantity, right? So that is right. Okay. So here fundamental and derived. Right? Fundamental physical quantities. So derived physical quantities, they are built up on one or more fundamental physical quantities, or you can go to the basics of it. For an example, as I said, speed. Speed is distance over time, right? Distance is a fundamental physical quantity. Time is a fundamental physical quantity. So the speed is what? A derived physical quantity, right? Derived physical quantity. Now, we'll go for this little bit. And I'm going to give you some examples. Acceleration. So you can say velocity over time. Velocity over time. Velocity is displacement over time. And again, you have time. So I try to give you some small exercise you to do. Area, length into length, volume, length into length into length, and density, mass over volume, that is mass over length into length into length, like kind of a work. And I'm going to give you some interesting activity. And now you have to copy down it only for today, because we have to send what? Send the tutorials. And when we send the tutorials, you can work on the tutorial itself, since it's the first day of the lesson. So we will not be able to 100% use the writing work. So we are going to give you the homework from that as well. Yes, I have given you few, and we'll go to the slides completely and see force, pressure, momentum, impulse, energy. Try to build these physical quantities based on their fundamentals and take a snapshot and send me in the WhatsApp group. I have added all of you to the WhatsApp group. Now send the answers. How force are connected. How force is connected to the fundamental physical quantity. How pressure is connected to the fundamental physical quantity. How momentum is connected to the fundamental quantities, impulse and energy. Do it. Now it is your exercise time, and I am available in the WhatsApp group. You can ask the questions there, and you have to take the photos and send the answers in the WhatsApp group. We are going to check one by one. Me and my staff will be available, and we are going to check one by one. right? Still take one by one. Force. How do you connect force there? How do you connect force there? We'll see what is the force coming here. Mass into acceleration, you can see that idea. So F equals ma Newton's law concept, right? Mass is a fundamental physical quantity, acceleration is not. So we have to break down acceleration into fundamental physical quantities, right? Acceleration, how do you break down the acceleration into fundamental physical quantity? Acceleration breakdown into the fundamental physical quantity. Velocity difference over time. And again, we have to divide the velocity into displacement over time. So mass, displacement, time and time broken down into the basics. So now we go to the screen. So you will see it nicely on the screen. So mass into acceleration, mass into displacement over time into time. So you can say force is made of mass into displacement, time into time. 4 quantities there, but practically 3 different types: mass, length, time. Pressure, force over area. Force is mass into length. Now we know that mass into displacement into time. So divide by area. So divide by area, length into length. So if you want, you can cut one displacement because it is a length. If you want, you can cut displacement, right? Length. So let's cut it and show you here. If you want, so here it is. Right. So if you want, you can cut this displacement with length. Yes. So you can say that it is mass over time and length. So you can say like that as well. So that is, yeah. Momentum is mass into velocity. Mass into velocity. So mass into velocity. Velocity is displacement over time. So mass into length over time. Impulse, a new one, right? So most of the people ask what is impulse there. So impulse is force into time. Force is already given. Mass into displacement into mass into displacement over time into time. So time, right? So if you want, again, as always, I tell you, so if you want, you can cut this, right? You can cut this, what? So not the displacement. So you can cut this time with this time. So you can say it's only mass displacement over time, right? If you want, you can keep it that way. So energy is force into displacement. Basically, I'm telling you the quantity name only, but when you go to the real definitions, that is slightly complicated and we are going to learn it slowly. Right? So force is mass into displacement over time into time. So on the other hand, displacement component still there, right? Displacement component still there. So this is that displacement. This is the entire thing coming from the force idea. So you can say mass into displacement over time into time, right? So that is that energy exercise. So yes. So now we are going to something very interesting that is called the supplementary units. Why they call supplementary? So we have to have a good chat. Now we have 3 calibers, right? 3 quantity sets. What is it? First of all, fundamental physical quantities. First of all, fundamental physical quantities, right? So first of all, fundamental. So the second, derived. Third, what? Supplementary. Why we need supplementary? Supplementary. Why do we need supplementary? What's the reason for supplementary? Now let me explain this properly, right? Using a good example. Number one, how do we recognize whether the quantity is fundamental or not? How do you recognize the quantity is fundamental or not? First, we need to go for the SI unit. If SI unit is defined fundamental list 7 with the support of universal constant based on an event or a universal constant, so we call them fundamental 7. We have done that. So you use fundamental to create another quantity, fundamental, at least 2 together, we create what? Derive. So we use this derive and connect with another fundamental, it is derive. Now we have 2 derives. We connect 2 derive together and then again it is derived. So when the scientists did this, they figured there are 2 additionals which is not coming under the definition of fundamentals or the definition of derived. So those 2 are known as what? Supplementary. Those 2 are known as supplement. Only 2. Remember, only 2. They are associated with angles. Radian and steradian. Radian and steradian. Supplementary quantity based on plane angle, unit radian. Plane angle, unit radian. Symbol radian. Right? RAD symbol, RAD red. Solid angle, steradian. SR, steradian. Radian, steradian. What is mean by a plane angle? What is mean by a solid angle? So let me do this with a small activity. I am gonna make a small cone. Okay. What's this? So this is a cone, right? Can we get a little bit of zoom in? Right, okay. That is the cone here. So you can see the cone, 3-dimensional. So the angle is 3-dimensional, that is measured in steradian. So now I use the same cone, right? 3-dimensional cone. I make it 2-dimensional. Right. Now this is 2-dimensional. This angle is measured in radians. Now it is 2-dimensional. Unlike the cone measured in steradian because it's a solid angle. And this one measured in radians, it is a plane angle. Simple. So those 2 are supplementary because we do not use them for any other purpose, only the angle measurements, right? So let's go for the supplementary quantities. And the derived units, now we know them and we have given a special idea. There are some derived units with special names and there are some derived units with no special name. There are some derived units with special name. There are some derived units with no special name. Okay. Derived physical quantities with special names for their units. Oh my God, what a big list here. Force. Measures in Newton. Symbol. Capital N, base unit, kilogram, meter per square second. Pressure, the physical quantity measures in Pascal. Pressure, the physical quantity measured in Pascal. Right. So it is the Pascal. Pascal, capital P, simple A. Kilogram, per meter per square second. Energy, joule. Joule, capital J, the symbol is capital J. Fundamental, kilogram, square meter per square second. Power, watt. Watt, capital W, the symbol, kilogram, square meter per cubic seconds. Frequency, hertz, hertz, hertz. Capital H, simple Z, simple Z. And per second is -1. That is the base unit or the fundamental unit. Electric charge, coulomb, coulomb. Capital C, the symbol, derived unit or the base unit is AS, ampere second. Ampere is a fundamental unit. Second is a fundamental unit. Coulomb is a derived unit with a special name. Electromotive force, potential difference, voltage, potential, everything, volt. I have only mentioned one. Electromotive force, voltage, potential difference. It is given in symbol of capital V. Kilogram, square meter, per cubic seconds, per ampere. Electrical resistance, ohm. This is the symbol, this is ohm. Symbol omega from Greek alphabet. Kilogram, square meter, per cubic second, per square ampere. Right? Capacity measures farad. Capital F, farad, capital F. S to the power 4, A to the power 2, meter to the power -2, and kilogram to the power -1. Magnetic flux, Weber, WB. Now, let me take something simple. I want to talk about this little bit. So, let's take this into the discussion a bit. All right. Okay. So, can you notice, did you notice something very weird in the column of the name? This column, just go through this column. What is it? Can you see how they have written Newton? This one, N. What is this N? N is simple N. This N is simple. But here, so you understand, this is simple. On the other hand, this one is capital. Why is that? Is it a mistake? What do you think? Is it a mistake? I don't think so. So why we write the simple letter for the name here? Why we write the simple letter for the name here? Why is that? Can you guess why? Because this is not the person. That is the name of the quantity. The name of the quantities here are the name of the quantities, name of the physical unit. This is the name of the physical unit. Right? So remember, notation wise it is capital N. Yes, but not capital N. Let me write this on the screen, on the board, and ask you something very interesting and bit funny. Huh? This is bit funny. This is bit funny. For an example, 10 newtons. 10 Newton. Which one is correct? This one or this one? Which one is correct? 10 newtons or 10 newtons? What do you think? N. My God, the first one is creepy. First one is creepy. 10 Newtons, either 10 Isaac Newtons or 10 family members of Isaac Newtons, like Pereiras. So isn't it crazy? 10 Newtons. My goodness, one Isaac Newton had invented these much of theories and we have to learn throughout our life, and you're talking about 10 Newtons. This one, the force. So science is pretty much well defined. In fact, it is all about learning it right. So you don't want to worry about capital symbols. This is not an English lesson. Don't misconcept. When you're talking about the person, you have to use the capital letter. That is English. When you're talking about the unit, you have to keep it in simple because that is SI unit system standard. But when you're talking about the persons, the unity is coming from a person's name, the symbols start from a capital letter. That's why the other letters are given that way. So it's a wonderful session. You understand a lot of things, what you have never ever heard sometimes, right? Now again, people, right? Again, we go back to the screen, digital screen. You go to the digital screen. Yes. Now I told you, like Newton here. Yes, we use the Newton here, but we use Newton. And on the other hand, when you go to what? The symbol of Newton. We go to symbol of Newton. We don't use the simple letter. Why? Because Newton, the special name, is given based on what? Based on person's name. When you're writing the full line, we keep it simple. When you're writing it with the unit, we write the proper capital letter. So we go to the next one also. Tesla. Now this is there in your notes. This is there in your notes. You don't have to worry about it. You go through it. Tesla, Pascal, Joule, Watt, Volt, Siemens, all are from people's names. So when you look at the people, name of the person, so when you go to the other side, yes, when you go to the other side, symbol, it must be capital letter, start from capital letter. Pascal, for an example, it's not one letter one. It is not one letter one. It is two letters, P-A, P-A. Okay. So what do we do? We keep P capital, A simple. Simple as that. Right. Becquerel, Gray, Sievers, Cat. Yeah. So this is a few, I give you a few minutes. Go through them and ask anything you want to clarify. So you can ask the questions in the chat. You can ask the questions in the WhatsApp group. Yes. Right, wonderful. I like the questions coming up here. Francis has given good question set, yes. Seha, that is a question to take into the discussion. I'll start from Seha's question. I start from Seha's question slowly. Number one, Francis' first question, so why the farad base unit kilogram comes in the end? No, actually, Francis, in advanced level, we don't take the exact order. How to keep it in the exact order is not very seriously concerned in advanced level. There are a lot of features and there are a lot of standards in SI system. It's a kind of a booklet with all the standards, how to write, what power to write first, and ascending order of powers or descending order of powers, or which quantity to be written first and all. So we are not taken it very seriously. Yes. So you said that people use, no, I did not say that people use standard units, because there are so many standard units. We are discussing only SI unit, that is called Standard International. Standard International is the SI system we use. As Sri Lankans, you have seen that the conference. So in that conference, we have seen that people agreed to take things into the use. So we are also in the community of SI system. That is a community, I told very clearly. SI is not just a standard, it is a community. So we community agreed to use a system, some sort of unit system. So that those are the unit systems we are using. And that's okay. And so why K is simple? And I answer Seha, I answer that question for you, because I told when the special names when the special name of the unit comes after naming from the person, so then only the first letter is capital. If the unit is named after a person, then the first letter is capital. In this case, catalyst, it is catalytic activity is not cattle, cat, that is not named after a person. That's why it is simple. If it is named after a person, if there was a person, a scientist who called cattle, so then we keep K as capital. And Krish asks, why, sir, the speed of light is used to make measurements? I don't get that one. I don't understand the question. Why speed of light is used to make measurements? I don't get the question properly. You try to rephrase the question. Why speed of light is used to make measurements? I don't know whether we can use speed of light to make measurements. I'm not very clear about the question, I think. Krish, why the specifically speed of light is used to define? Yeah, okay. If that is the question, speed of light is a constant in vacuum. That's why. All electromagnetic waves are going in vacuum at the same speed. That is speed of light. So we call it speed of light because light is the most popular electromagnetic wave, travels in vacuum for us. There are only 7 basic SI units. Dinura, yes. There are only 7 basic SI units. There are 7 fundamental physical quantities. Yes, perfect. That's right. Hope you all understood the questions. Krish, did you understand the question? Krish, did you understand what I said? Why specifically speed of light? Because all fundamental physical quantities are defined using universal constants. Speed of light in vacuum is a universal constant. We believe that it is not a variable. Hope Francis, Seha and Krish got your answers. If you're completely okay with it, please let me know, then we can move to the next part. And that is the last part. Right, Francis? Wonderful. Nice. Join the group and keep asking questions like this. And that will help the others also to understand sometimes. It's not sometimes you ask the question, it's not only for you. Sometimes people have those doubts, they're a little bit scared to ask the question, or sometimes they are a little bit don't understand how to ask the question. We have situations like that, isn't it? Sometimes we have a question, we have a doubt. Sometimes we can't put into correct words and ask. So what you're supposed to do is, like, you put the question, whatever the way you feel. Please use the groups and these chats very wisely, because we have given you an opportunity. It's a wonderful opportunity to learn these things. Today's lesson is absolutely free. So you're learning it very nicely, and I'm so happy to see people asking questions like this. Yes, Disinu, yes, physics is a very interesting subject. So that's one reason I quit engineering and joined teaching physics, because I feel physics is one of the most interesting subjects to teach, because it's around everywhere, like, whatever the doubts, whatever the questions, whatever the things you observe, you touch, you feel, you listen, everything can be explained. How they happen, how it work, only from one subject, that is physics. So that's an interesting subject. Let's make it more interesting, because it's you, not me. You may have to make it interesting. You come up with questions, you study, you go through it, you find some videos, put into the group. My groups are not only for me. If you people find good videos, please put into the group. And if you're really, confident about their very interesting ones, put into the group. I will, if you put say a lot of good videos, I will put into the admin panel also. So then you can post it into the community as well. So we are a community. We are live physics community. This is not live physics. This is not about the classes. This is live physics. We are living in this world, physics world, live physics science community. So I will make you admin of the communities and the channels, so you can post more videos, watch. Social media is not a bad thing. I feel social media is a very interesting platform. So the TikTok, Insta, Facebook, YouTube, so you can find a lot of knowledge, lot of scientific stuff. Sometimes we can't hear in Sri Lanka. We don't have, I mean, Online Mahagedara is trying to give the best online experience for you guys. But on the other hand, the videos, YouTube channels, most of the YouTube videos we see are not high quality, because we are, having a little bit of budget concerns. We can't do good productions, huge investments we can't make. So therefore, like foreign countries, universities, they do a lot of YouTube videos for the community service, because you can watch them and you can learn things. So they have a lot of resources, they have funding. So therefore, like, get exposed to the world, and especially you are an English medium student. So when you do English medium, so you understand things. And honestly, people who do not understand any words or something, please don't hesitate. None of us are perfect, right? None of us know everything. Firstly, I clearly said that, right? Even Einstein said that he doesn't know physics, right? So even the languages you don't know sometimes, the word terms, please ask them, search internet, find them. And if you don't know, ask from us. If we don't know, we search, we teach. We are not, because science is not something we can learn and study and finish and teach. It updates every day. Sometimes I told you, like 2018, they changed the definitions. So it's like that. So you don't have to be concerned about asking things. සමහරලාට අපිට පොඩි එකක් කරනවා නේද? මේ මගෙන් ළමයි ප්‍රශ්න අහනකොට අහනවා, "සර්, මේක මෝඩ ප්‍රශ්නයක් සර්" කියලා එහෙම පටන් ගන්නවා. I never believe that you ask stupid questions. I really believe your questions are very serious. Your questions are the most important parts for me to teach. Because professor also believe the same way. Professor also believe the same way. Your questions are the questions we need to address. So don't ever think that your questions may be like stupid question or moda prashna ho mona hari hema kiyala hitanna nathuwa. Just drop it. Right? Just drop it and be relaxed. Try to learn this. Online learning going to be very interesting. So yes, physical classes, we are going to give the same experience as you are learning in a physical class. Right? Francis asking is a good question. In O levels distance we used D, but today we were using distance as S. No, we didn't use distance as S. Displacement is S. Anyway, I will tell you the honest reason. Because both letters are pretty good lesson. Sorry, both letters are very nice letters. S is always better, and D is also better. That's why SD is the best. Because S is also using a distance, displacement, distance, displacement, they interchange. So S is a better letter. S is a nice letter, so that's why we use S here. Displacement, most of the time displacement they use S in standard formula. Yeah, that's how it is. Right, let's go to the next part. Right, I think hope you all had a good chat. Let's finish this off nicely. We started well and we'll finish this well. Right, prefixes and suffixes. Derive physical quantities with no special names. Area, no special name. Area, no special name. Why not? No, because it's meter square. So it is square of the meter. We are not putting a new name for that. Length, breadth, height, volume, it is m to the power 3. So we call cubic meter. Cubic meter is not a special name. Cubic meter is just third power of the meter. Density, mass over volume. Mass is kilogram and volume is m to the power minus 3. M to the power minus 3. Velocity, displacement over time. So that is displacement measures in meter per second. Velocity unit is meter per second. How do you read it? Meter per second. Acceleration, meter per square second. Meter per square second. Momentum, kilogram meter per second. Actually speaking, momentum we go with another unit called Newton second. Newton second, so kilogram meter per second. Now you understand like why they have used these, special names and no special names. One reason you can see these are like only two lines. Like here in this case it's meter squared, one quantity and square, cube, and two units here and 2 units here. So when you go to 3 and more, they try to define a single letter, because otherwise we have to right? Right. So yes, now we'll see that. Now you can see that what I was talking about here. Now this is like 3 quantities here. So 2 physical quantities in this case. When you have 2 letters, so we are okay with that. When you go to 3 and more, it will be like little bit. It will be like little bit inconvenient to write. It will be like little bit inconvenient to write. When it is little bit inconvenient and too long to write, we introduce a new quantity, new word with 1 letter. So that's how it is. So that is interesting. And then multiples and submultiples. Multiples and submultiples. Oh my God. So you'll start from the bottom, right? So we start from the bottom. Start from the bottom, right? 1. So here it is 1. So 1, we have no submultiple because 1 is the base. So 1, 10 times. So we call deca. 100 times hecto. 1000 times kilo. Million times mega. Billion times giga. Trillion times tera. So now you can see peta. Spellings. Natang pitakotu kilitai. P-E-T-A. Right? Peta. So at least to that level is important. Right? So why do we use these submultiples? Because otherwise you have to write the numbers like this. Otherwise you have to write the numbers this long. So without writing it this long, what we can do, without writing this long, what we can do, we can put just 1 letter, capital Y. Capital Y. So then you can, this long letter set can be contracted to 1 letter, Y, 1 letter, Z, 1 letter, E, like that. Okay. And the other side, the smaller side, so we call the submultiple side. So we start from deci, centi, milli, micro, nano, pico, femto, at least up to femto. At least up to femto. Right? We need to know at least up to femto, 10 to the power minus 15. Decimeter, centimeter, millimeter, micrometer, nanometer, picometer, picofarad, etc. Whatever the unit, you can put the prefix in front, multiple or the submultiple. You can put the prefix in front, right? Okay. So please download the note and go through it one more time and finish it off. And I'm going to teach you the rules, the last set of rules, the basic rules. They are not very complicated rules. You read the entire thing, because when you're done, we can give you the homework, right? So please go through it one more time and ask anything you don't understand from the note, because we have given the PDF also, but the theory note is bigger than the PDF. You're getting the tutorial and I will show you what you get, right? There are so many things to give you. There are so many things to give you. Number 1, your tutorial one. Here, this one. Right? So you're getting the tutorial, that is measurement. And from the other side, you have my publications. I have published 18 books for the entire syllabus. This is the only English medium book series in the country which covers theory, short questions, and especially what you call past papers. Past papers are there from 1980 onwards. If the lesson is there in the syllabus, 1980 to the most recent, and it include the answers, reviews, everything what you need. So you can learn the self-guide, these booklets, and books are given to online people. Yes. Other than that, you get the tutorials one by one. And then there is another book. This is not a leaflet or something. This covers, first day I showed you a little bit. There are workbook. So put your marks and everything, and I'll be sending this to your home addresses. And this is the mobile application, because we have developed a self-learning mobile application for you people that include all the recordings, videos, live, the past papers, books, ebooks, and not only ebooks. Other than that, you have the AI support model. So there is AI assistant called SDEE, right? So that this particular AI assistant, you can ask questions and clarify doubts. It's a kind of an individual class, yeah, with my face and my voice and everything. Yes. So other than that, your model papers, past paper planners there. So, and your self-evaluation sheets, your time management planners, all will be sent. Homework tutorials, weekly tutorials will be sent, and you can download the PDF version, and in the mobile application you can go through the ebook as well, right? So yeah, so all these things will be given to you, sent to your home address. When you receive this, we'll have another chat how to use these parts separately, right? Yeah, please remember to get into the WhatsApp group. Please remember to join the WhatsApp group. In the WhatsApp group, or communicate, and that also I should write, I think, even though it's there everywhere. So these are the hotline numbers. This is the hotline number to, you know, get into the WhatsApp groups and all. Hotline number. That is WhatsApp group. We'll all are there in the WhatsApp group. And I'm also there in WhatsApp group. Right. And then the publication number, not 7202202222. All are the same numbers with different service providers. This is a publication. If you want to get the books, publications. And then my number, add it here, note 770220222. Again, the same number, dialogue number, Mobitel number, hotline, dialogue number, my number, and the hush number, publication number. So this is just for academic reasons only. Then හොඳට මතක තියාගන්න මේක සිංහලෙන්ම කියන්න. මේ නම්බර් එකට දාලා class times පොත් ඉල්ලන්න, tutes ඉල්ලන්න ඒව කරන්න එපා. මගේ personal number එක ඔයගොල්ලන්ට දෙන්නේ ලොකු trust එකකින් ඔයගොල්ලෝ හරියට ඒක use කරයි කියලා. ඔයා ඒකට කතා කරන්න ඕනේ මොනවා අහගන්නද? ඔයාගේ academic matter එකක් ආවොත් පමණයි. ඔයාට personal matter එකක් ආවොත්. ළමයින්ට එක academically බලපාන personal issues ආවොත්. එතකොට ඒවට කතා කරන්න තේරෙන්නේ නැති ප්‍රශ්න තියෙන එකක් ආවොත්, lesson එකක මොන හරි දන්නේ නැති කැලලක් තිබුණොත්, හරි? එහෙම නැත්නම් ඔයාලගේ payments වල ප්‍රශ්නයක් ආවොත්, so that you can talk to me in person. Yes. But other numbers are for different stuff. මට කතා කරලා tute ඉල්ලන්න එපා. Tutes පිළිබඳ ප්‍රශ්න මේ number එකට කතා කරන්න. Books පිළිබඳ ප්‍රශ්න මේ number එකට කතා කරන්න. Online class වල මොනවා හරි ගැටලුවක් ආවොත් either use the hotline, online hotline number, SyZyGy.lk online මහගෙදර number එකත් මම තව චුට්ටකින් දාන්නම්. ඒක මගේ අතේ දැන්ට නැහැ. ඒක එහෙම නැත්තම් ඒගොල්ලෝ display කරයි. ඒගොල්ලන්ට පුළුවන් නේද display කරන්න අපිට? Yes, ඒගොල්ලෝ display කරයි දැන් අපිට. එතකොට එතනින් ඔයාට ගන්න පුළුවන්. එහෙම නැත්තම් අපිත් එක්ක මොන හරි ඒ ඔන්ලයින් එකට සම්බන්ධයක් ඒගොල්ලන්ගේ පැත්තෙන් හරි අපේ පැත්තෙන් හරි වෙන්න ඕන. අපි මේක කොහොමත් අපේ හොට්ලයින් එක ඒකටත් ඔයාලට කතා කරන්න පුළුවන්. Right. right. දැන් number එක අපේ screen එකේ යටින් display වෙනවා කියලා අපේ පාලක මැදිරියෙන් කියනවා. අන්න හරි. එතන ඒක දැන් දාලා තින්නේ. හැමෝටම මේක පේනවා. right? ඒ තමයි online මහගෙදර hotline එක. ඒකටත් ඔයාලට කතා කරන්න පුළුවන් online classes ප්‍රශ්න આવොත්. මොකද අපිට කතා කරත් අපි ආයි ඒගොල්ලන්ට තමයි කියන්න ඕනේ directly ඔයාලට පුළුවන් ඒගොල්ලන්ට කියන්න. අපේ පැත්තට අවශ්‍ය නම් WhatsApp group එකට එන්න ඕන නම් මොන හරි එහෙම ප්‍රශ්න આવොත් මේ numbers දෙකෙන් ඕන එකට කතා කරන්න. මේ ගොඩක් වෙලාවට WhatsApp වලින් තමයි පහසු. So use WhatsApp to communicate as much as you can. පුළුවන් තරම් අඩු කරන්න. හැබැයි අපි ඔයාට බොහෝම වගකීමෙන් ඔයාට මගේ personal number එකක් දීලා තිනවා. ඒකත් misuse කරන්න එපා. මොකද අපි classes වල ඉන්නේ. දැන් ඔයා මේ වෙලාවේ මම class එකක ඉන්න වෙලාවේ ඔයා කතා කරලා sir මට tute එක හම්බුන්නේ නැහැ කියලා කිව්වොත් මට ආයි කියන්න එන්නේ ඔයාට එකම දෙයයි. මොකද්ද? hotline එකට කතා කරලා පොඩ්ඩක් inform කරන්න කියලා. හරිද? එහෙම hotline එකට කතා කරලා උනේ නැත්නම් ඔයාට පුළුවන් WhatsApp group එකේ මගේ number එක tag කරලා request එක දාන්න. මම hotline එකට කිව්වා මේක සිද්ධ වුණේ නැහැ. පොඩ්ඩක් බලන්න ආපහු කියලා. එහෙම අපිට වෙන්න පුළුවන් නේ. ගොඩාක් calls එනවා, ගොඩාක් messages වැටෙනවා. ඒතකොට එහෙම පොඩි හරි මොන mistake එකක් වුණොත්, පොඩි හරි ප්‍රමාදයක් වුණොත් අපිට එහෙම tag කරලා කියන්න පුළුවන් තරම් call කරන එක අඩු කරන්න මගේ number එකට. ඔයා group එකේම ආව tag කරන්න මොන හරි ගැටලුවක් ආවොත්. Right? So let's go to finish the work now. Rules to be followed when using SI units. In SI system, symbols, units representing a name of a person always start with a capital letter. Those units which are not names of a person are written in simple letters. I have already taught what Newton and Kelvin, the names. Unit of moment, Newton meter. You can see Newton is there. From a name of a person, meter is not a name of a person. Right? Right? Okay, part A. All fundamental units which are not dedicated for a name of a person are written in simple letters. We know that when writing derived units and multiples of units, a dot is not placed in between two units. No dot, but there is a space. You can see n and m to the power minus 2, there is a small space, Newton per square meter. But milliampere, so you can see m is not meter in this case. Second case, milliampere, so m is not what? Not a unit here. M is not a unit here. So m is what? M is milli. So that's a prefix. So you don't keep the space between. Here you keep the space between here. And all these letters are not italic. They are normal font types. When writing the numerical value of the physical quantity, it is written behind the numerical value. We don't write M10, we write 10M. Not S20, we write 20S like that. Units are not given in the plural forms. Units are not given in the plural forms. Important, right? Meters, seconds, not very nice to tell in English medium classes. When writing derived physical quantities, a space is kept between the fundamental units. Example, you can see that unit of moment is given accurately, Newton space meter. When writing a multiple or submultiple of a unit, no space is kept there. When writing derived physical quantities, usually they are written so that the power of the fundamental physical quantities is to be reduced in their order. Units cannot be added. When added, the same unit is obtained. So 15 centimeter plus 15 centimeter, that is 15 centimeter plus 5 centimeter, that is 20 centimeter. We don't add this centimeter is centimeter, not 2 centimeters. Unit cannot be subtracted. Even you subtract, you get the same unit, like 20 kilogram minus 2 kilogram, 18 kilogram. We don't cut kilogram there because we are not subtracting unit. Unit can be multiplied or divided. So kilogram into meter square second. So we can say kilogram meter square second, that is equivalent to. You can see that this is equivalent to Newton. So simple. Yeah. General features, unit cannot be divided. So unit can be divided. So square meter divided by meter is meter because 1 meter is cancelled off. Some quantities have no units like relative density, refractive index, coefficient of friction. It is kind of a summary of the day, isn't it? In a correct equation, the unit in the right hand side are equal to the left hand side. For an example, pressure equals H rho G. So this is pressure, so this part also pressure. So this measures in Pascal, this also measures in Pascal. So yeah, incorrect equations, if there are terms involving addition, subtraction, those units should be equal. If it is not equal, the equation is wrong. For an example, P is equal to Q plus R. So Q and R must have the same unit of P, simple. So similarly, when you're subtracting Y minus Z, so Y unit is same as Z unit is same as X. So unit of X is equal to unit of Y is equal to unit of Z, right? So all the terms must be the same. So you can see that A equals B plus C divided by D. So unit of A is equal to unit of B is equal to unit of C over D. So that's the end of the lesson. So let's wind this up nicely. Right. So to wind up this, so teaching process is very clearly given to you. On the other side, I like to tell you this is how we work for next 2 years. Physics is not an easy subject. So it is some kind of tough work. You all supposed to commit fully. This is a class which is really interactive from the beginning to end. So you all have to be very alert. We need you to communicate. If you don't communicate, I can't help you. Right? So we are going to give you like amazing experience with several aspects. This is just the beginning of it. We did not do everything on the first day. This is 1.2. We started 1.1. We did 1.2 today. And I'm planning to do 1.1 again here in this environment and put a recording in the groups. So you can see that one more time and go through it and understand what is physics. Other than that, remember, this program is for 104 weeks. I have scheduled, and that schedule is there in the purple color book I showed you. And you're getting it printed, copied to your home addresses. In that book, we have given you 104 weeks plan. I come to this classroom, the digital classroom, 104 weeks from here to another 2 years. Every year it is 52 weeks, another 52 weeks. Exactly in 2 years, we are going to finish the syllabus. Trust me, March 31st, 2028, we are done with the syllabus. April is the revision week. May, June, July, we do questions, papers, full exams. And we are going to arrange everything online for you guys who are joining online. If you really want to write the papers physically, we are making arrangement for that as well. So everything will be there as normal as in a physical class. So we'll join the next session, the same platform, same Friday at the same time through the same classroom, right? Good night, and be there in the WhatsApp group, get the updates and study this part, collect the tools, do the homework, and come to the next lesson next week. Good night.
SyZyGy Online Mahakethara.
හොඳම ගුරුවරුන්ගෙන් හොඳම තාක්ෂණයෙන් ඉගෙන ගන්න. SyZyGy online මහගෙදර සිංහල සහ ඉංග්‍රීසි මාධ්‍යයෙන් උසස් පෙළ සියලු විෂයන්වල පන්ති දැන් ඔබේ නිවසටම. Combined Maths දුෂ්‍යන්ත මහබදුගේ, Chemistry චරිත දිසානායක, Physics සමිත රත්නායක, Biology චරිත මුණසිංහ,
English medium science, combined maths, Dushyanta Mahabuduke, biology, Chartha Munasinghe, physics, Janitu Leelananda, physics, Sanjeewa Dharmawardhana, chemistry, Nirandika Jayawardhana,
accounting, Hemal Pereira, business studies, Charaka Dhananjaya, economics, Kumar Bagasinghe, economics, Lucky Chaturanga, agriculture science, Dinesh Atukorala, ICT, Lasita Prasad, SFT, Sadun Priyankara, ET, UD Madhusank Saha, Tulanj Rusiru, BST, Dinesh Atukorala. Sinhala Sujeeva Sirimevan, Media Asela Bandaranayaka, Political Science Nilu Tennakon, Geography Ruwanmali Chai Vikrama, History Chandima Vijay Bandara, History